Right. Good afternoon or good morning, depending on where you are joining us from. My name is Dorina Cousins, and I am the Director of Membership here at ITSA or ITS America. I would like to welcome you all to today's session, which is AI Transforming Transportation. And this webinar will be presented by Microsoft and Parsons or members. Before we start today's session, I would like to go over a few logistics and housekeeping items. As you may have noticed, all your participants' lines are muted today. That way we can avoid any interruptions or background noise. Our speakers do, however, encourage that you provide questions in the Q&A pod, which you could find at the lower toolbar of your screen. This recording or this webinar will be recorded for you to go back and view at a later date. We also ask that if you wish to use the closed caption feature, it is enabled, and that is also at the bottom of your screen. And with that said, I would like to turn things over to Samir, who will be kicking things off. Thank you.
Great. Thank you, Deanna. And a thank you to ITS America for hosting today's webinar event. Thanks to all of you for taking the time out of your busy schedules for joining us today. And thanks to Parsons for joining me today to share our mutual point of view on how AI is and will continue to radically transform transportation, specifically for state and local DOTs around traffic management. Now, there is a really good reason why Parsons is joining me today, and that is because on March 8th, Parsons announced a new global strategic partnership with Microsoft that really combines the power of Microsoft's Azure Cloud and our AI technologies with Parsons' expertise in a wide range of global infrastructure markets and national security. So we couldn't be more excited about this partnership with Parsons and how we see it accelerating the adoption of AI, digital twins, and smart infrastructure to support our customers with really unlocking operational efficiencies and strengthening really the world's critical infrastructure at large. Now, before we dive into AI, I'd like to first start with providing sort of a key overview of the challenges that we're hearing state and local DOTs are being faced with today. And the first challenge should be familiar to all of us, right? Which is growing road congestion, which is effectively when demand for roadway travel exceeds supply of roadways available. Now, some key stats here. In 2022, US drivers estimated to have lost 51 hours in congestion. So that's about an hour every week. Now, what's more concerning is that 15 hours, that's actually 15 hours lost more than 2021. So this is actually trending in the wrong direction. Now, let's talk about road safety. Now, the National Highway Traffic Safety Administration recently estimated that almost 32,000 people died in traffic crashes in the first 9 months of 2022. Now that's a 0.2% decrease from 2021, a slight decrease, but clearly there is more progress that needs to be made to keep our roads and our travelers safe. Now, regarding transportation infrastructure, many of you may remember that the American Society of Civil Engineers published a report card on the state and the condition of various types of public critical infrastructure. And in that report, they highlighted that the nation's roads were rated as a D. And a D, according to the ASCE, is defined as poor and at risk. And additionally, they rated bridge infrastructure as a C, which is defined as mediocre and requires attention. Now, the good news is that there's a significant amount of funding from the Infrastructure Investment and Jobs Act, or IIJA, which is now in its second year, and money continues to flow to DOTs to support them with bringing this infrastructure to a state of good repair. But There is a large backlog of work to modernize. There are resource constraints. There is, of course, inflation that's causing the cost of materials to go up. So overall, money is flowing, but the effort around modernizing this critical transportation infrastructure to a state of good repair continues to be a challenge. So enough of the doom and gloom. Let's pivot and talk about how AI is currently being applied in state and local DOTs to address many of the challenges that I shared earlier. Now, we're seeing machine learning models being applied in a variety of ways to do things like predict congestion and travel time loss. We're seeing ML being applied to predict how safe our road networks are down to the road segment level. From a detection perspective, we're seeing AI being applied to traffic cameras and other sensors to automate the detection of traffic incidents, to automate the detection of multimodal demand, like the detection of pedestrians and bicyclists, which is critical data for traffic operators to ensure the safe and efficient movement of people, regardless of the mode that they're leveraging to move. AI is also now being used to automate detection on common non-recurring congestion activity, like detecting wrong-way drivers or debris that may hit the road network. And these are just a few examples of how AI is more broadly being used by state and local DOTs, but there's now more advanced applications of AI entering the market to further support DOTs with addressing the challenges we talked about earlier. Now, at this point, what I'd like to do is introduce Guada Casuso, and she's the Vice President of Technology and Innovation with Parsons. And she's going to share Parsons' perspective on this topic and how they're integrating AI into their solution offerings to ensure DOTs can truly harness the full power of AI to help DOTs achieve their key outcomes. Guada, I'm going to hand it off to you.
Perfect. Thank you so much, Samir. Such a pleasure to be here. I would say this is another opportunity to celebrate the partnership between Microsoft and Parsons. I also want to say thanks to ITS America for the opportunity to share what Parsons is doing in this space and how we continue innovating. So I'm going to start just setting a context on which is our team. So Richard, who will speak later, and I, we are part of Connected Communities at Parsons. And we are on a mission to design, build, and deliver the infrastructure that helps protect and connect communities across the globe. And here is just a list of some of the technologies that we are developing and implementing within our group. So ATMS systems, and we will speak about iNET, traffic planning and engineering, advanced tooling, and ITS. And of course, we focus on emergency transportation operations. Again, safety and the protection of communities is a key part of what we do. And let's talk about iNET. So in iNET, basically, we have a set of modules. And let me say, iNET is an advanced solution, software solution that really helps connecting the traffic networks. We have different components, and the modules are based on base modules that you can think about maps, you can think about different systems that set the platform so we can add connectivity to different devices that really fit the platform. We have connectivity with external sources through APIs, different modules. We have a solid ecosystem and the intelligence management modules. And that, I think, is one of the core pieces ready for innovation and to bring advanced artificial intelligence.
Good deal. Thank you, Guada. And when I look at this list of modules under the Intelligent Management Suite, truly impressive in terms of the breadth, right, of capabilities, as well as the various use cases, right, that I believe would resonate with the state and local DOTs that are joining today's webinar. Now, to get deeper into iNET, how it works, and really how AI is being applied across these modules, I want to introduce Richard Chalinsky. Richard is a VP with Parsons, and he's going to walk us through the story of iNET and these modules and give examples of how iNET is really transforming services for state and local DOTs, infusing AI in ways that are far beyond what is common in the market today. Richard, I'm going to hand it off to you.
Thank you, Samir. Yeah, and I'd like to also thank ITS America for the opportunity to talk a little bit about our iNET traffic management solution and what it does in terms of benefits to our customers, those agencies, in terms of managing their transportation infrastructure. So I'll just start with a very basic overview of what does iNET do. What iNET does, traffic management solution, constantly monitors conditions on your transportation network, basically by talking to sensors in the field, as well as data feeds from other systems that are monitoring the transportation network. Then we proceed to detect and verify. So we analyze those sensor inputs, looking for abnormalities, things that are sort of out of what you normally expect to happen during this time of day, and identify whether those are potentially incidents. And then we're prompting essentially operators at a TMC to confirm them. Then what do we do next? Well, we have to take all that input and then say, what is the best set of mitigation measures that we're going to apply to try and solve or mitigate the incident or the additional congestion that's actually building up. And for that, we make a decision using a decision support solution. Decision support solutions have been part of our solution from its beginning, its inception. But nowadays, we're starting to leverage things like AI and machine learning in the decision support system to try and provide better decisions for the transportation agency. Also, with the partnership with Microsoft, we want to leverage Microsoft's Azure cloud-based services and big data services to, again, take us to the next level in terms of decision making. And with those decisions, then we come up with a series of actions. And that consists of things like controlling devices in the field, whether you've got dynamic message signs providing driver advisories to motorists. If you're a city, you've got traffic signals infrastructure, controlling the throughput on your arterial network. We're basically controlling those as well as sending notifications to other agencies, as well as emergency services agencies that are dispatched in response to support the event. And then all this data is collected in a massive storage, a repository, data lake, and then we provide an analytics and data exchange engine in order to further analyze that data. So this is an area that's also ripe for extending and enhancing with Microsoft support as part of this strategic relationship. In order to take advantage of AI and machine learning to really understand all the data that's being collected for systems that have been running for years and being able to make better decisions then going forward. So in terms of the smart mobility use case, in terms of monitoring, we're talking about collecting data from the vehicles and the roadway sensors, things like speeds, volumes, and also what's the current status of your signal timing on the arterial network. With that, we actually then take that data, and we've got incident detection algorithms within our current product, and we're starting to introduce machine learning, and I'll talk a little bit more about that capability and where we're starting to leverage it within our iNET product. And also we're collecting data from in-vehicle applications, as well as working with third-party data probe providers to provide us additional information on the broader transportation network. And within the TMC operations, we're using CCTV cameras, of which most agencies have pretty much an existing plant of CCTV network to verify the accident, which a TMC operator does. In terms of making decisions, well, again, we're coming up with the best response in terms of using the signals or the signage, ITS signage that the agency has on the roadway to provide the best mitigation measures to reduce congestion and provide travel time reliability. And then we just go forward and implement those responses. In other words, control all the devices within the transportation network, provide driver advisories via DMS signs, or also providing that to services that are providing it to new in-vehicle systems. And then also dispatching messages to local police and service patrols that are managed by the agency's traffic management center. And again, all the data is stored, compared against previous records, so that we can actually provide further insights in terms of operations, and again, allow the agency to make better decisions in the future. Now I'd like to actually talk a little bit more detail about some of the areas where we're within our solution where we are using further, basically more detailed intelligence as well as AI. One area is we've got a newer video analytics module, which we've deployed in a couple of projects in the past couple of years. And this is leveraging AI machine learning and deep learning neural networks to identify and track objects within the CCTV video image. Now, a lot of our agency customers have already an existing CCTV plant that they've been building out for years. And the solution really takes advantage of those CCTV feeds that are already at the TMC center. And with that, then we can extract data out of it, including vehicle pedestrian and bicycle counts, vehicle classifications and speed, stopped and wrong way vehicle detection as well. And the nice thing about it is it already makes effective use of an already existing CCTV plant. Another module that we use is our intelligent signal response module. Now, iNET itself has a traffic signals module, which is designed to monitor, manage, and control intersection signals within an arterial network. So the cities can actually then manage their throughput on their arterial network. Traffic signal response control is basically a new twist on the old traffic response algorithm. Instead of using an old algorithm, we're actually leveraging an AI inference engine in order to respond to detection of abnormal traffic conditions by either selecting an existing timing plan on the controller that better matches the current traffic conditions. So an example of this is, let's say during the off-peak periods, you're actually seeing an abnormal level of higher level of congestion, higher volumes, higher occupancy, but essentially the existing time of day plan, the off-peak plan, is still running. Well, the system will actually detect that and say, okay, well, maybe it's better off to use our peak period plan for this. It will better match the traffic conditions. So the system will recognize that using its rules and the AI inference engine, and then issue a control to change to that peak period timing plan during the off-peak. And when the congestion dissipates, it'll tell it to switch back, all automatically without operator intervention, okay? And the rules themselves are initially created and calibrated, but then essentially the traffic engineer can actually then look and use, we actually have all these charts on the right-hand side here where they can actually see the detailed decision-making that the AI engine is actually making to determine what are the inputs that actually cause the problem. So not only is there an AI engine there, but you can actually see what the engine's doing and why the decision was made. Another area where we're actually using intelligence and leveraging it in our solution is with our intelligent intersection module. In this way, we've come up with what we consider a better way to retime traffic signals, sorry. And this is where we're actually leveraging the capabilities of modern traffic signal controllers by collecting the high resolution data that's available on these controllers, using that high resolution data in addition with and fusing it with data collected from probes, where we're getting vehicle trajectories from probe data services. And with that, really analyzing to see whether the signal timing is actually degrading. Now, this is not something we're doing on a hour-by-hour basis or even a real-time basis. This is something we're looking for the degradation of traffic signal timing over days, months, and weeks, so that we can then advise the agency that, oh, hey, your signal timing is starting to degrade. Maybe you should change the cycle time, which will better match the ongoing long-term traffic conditions. And this then provides the agency with that ability to then say, yeah, I agree with that recommendation, and then proceed and implement it. This module also comes with standard signal performance measures, the standard ATSBMs, includes a dynamic map where the operators can actually view where we're getting hotspots, as well as provide situational awareness. So it's another area where we're actually leveraging intelligence and AI. Now I'd like to talk about a couple of agency examples where they're using these intelligence on street. So one agency we're working with is the city of Dubuque. Now, Dubuque is a small city on the eastern side of Iowa and bordering on the Mississippi River. And it has a program that it developed called the Smart Traffic Routing with Efficient and Effective Traffic Systems, or so-called STREETS program. Now, their STREETS program, they applied for some federal funding and they got a grant for improvements to their ITS infrastructure. And why did they want to do it? They have a situation where they've got a major highway, US 20, that actually runs through the city and actually then crosses the Mississippi River. Congestion does affect, when congestion does happen on the highway, it does affect parallel arterials. But it's a combination of both local traffic as well as through traffic. And there are several arterial alternatives that are available, and the agency wanted to make better use of these alternatives. So with that, they created this project, and we're helping them actually apply our iNET ATMS to provide more intelligent tools to achieve their outcomes. So what are we actually doing? Well, when an incident occurs on, say, US 20, and this is the bottom left-hand diagram there shows that, traffic does have the option of using a parallel arterial, but how do the drivers actually know that? At this point, there is no on-street driver advisory. So we're looking at deploying dynamic message signs on US 20, as well as being able to adjust the signal timing to actually manage that additional traffic that will be diverting onto the city arterial streets going to downtown. So it's a combination of not just one ITS mitigation measure, but a combination of them that'll actually then achieve the results that they actually want. And how do those components actually work within the iNET architecture? So this is a iNET concept architecture diagram, and I've outlined in red where we've got our intelligent components that I've just described here. So on the top left, the first red box there on the top left is our iNET video analytics module. And what that is doing is that is collecting the video images from the video streams from the existing CCTV system. Dubuque itself has actually established a very, I guess, extensive CCTV network within their city and have a whole host of cameras available, camera feeds available that can be utilized, and we can extract vehicle traffic data from those camera images. So we're integrating with that existing CCTV system at the central in this case, and using our VA module to then provide traffic detector data. Now that traffic detector data is then analyzed for anomalies. And how are we actually doing that is we're then using also a microsimulation module over in the top right-hand side. We're using a microsimulation module, which actually takes all the traffic data we've collected, runs it through, and actually looks at what traffic will be, not now, but also 15 minutes from now or an hour from now, calculates what sort of measures of effectiveness we'll see at that time. In this case, we're looking for what will the traffic delays be at that time. And then when we are thinking we're going to see an anomaly, we're trying to get ahead of the situation. So this is where we're actually predicting upcoming congestion that's starting now that may grow and affect the effective conditions on the roadway. And once that anomaly is detected, we actually determine, using our operation decision support system, we determine a set of measures that we want to use, providing the driver's advisory, for example, adjusting the signal timings on the parallel arterial routes. And then depending on how the number of strategies we come up with, we say, well, how are we going to pick the best strategy here? For that, we actually use a microsimulation model as well and run it through prediction with each of the sets of mitigation measures to find out which one will actually essentially improve the delay statistics. In other words, reduce the amount of delay experienced by travelers overall in the corridor, not on a specific roadway, but overall in the corridor. And that's what we're looking at. We're looking at improving overall corridor delays. And then with that, we would actually then apply controls through our intelligent response modules out to the traffic signal controllers as well. The next example I want to talk about is San Diego, the San Diego Integrated Corridor Management System. And this was a project that was established by the San Diego Association of Governments, SANDAG. It's been running for many number of years already. It was one of the first two integrated corridor management systems that were funded by federally funded ICMSs. And SANDAG set up this particular program in order to really proactively manage congestion within the corridor. And this is the I-15 corridor in northern San Diego. And the whole idea was to maximize system capacity in the entire corridor. And that was not only on the roadways, but also the all modes, looking at maximizing capacity on transit, as well as the arterial network and the main highway network. We go to the next slide and I can talk a little bit more about that. So the map on the right-hand side sort of shows you the I-15 corridor. And this runs in the north, it's in the northern part of San Diego County. At the top end, the northern end, we see the city of Escondido. Then the I-15 runs through the city of Poway and then down into the city of San Diego. So one element of this integrated corridor management system is the number of partners and stakeholders involved. We have 3 cities involved directly on the corridor. Then we have obviously the San Diego Association of Governments, which is the overall regional government, MTS, the transit agency, and Caltrans, the agency responsible for the highway network. And all must work in coordination in order to try and reduce the amount of delay over the entire corridor. So we have a number of facilities that that SANDAG wanted to control as part of this. They control the mainline lanes of the highway using ramp meters. Also, there's express lanes that run down the center of the I-15, and those express lanes are tolled, but there is the opportunity to open them up to all traffic if there's major congestion on the freeway itself. There's also a bus rapid transit network that runs down the freeway with stations along the freeway. And in this case, they're looking at also encouraging under heavy regular congestion, they're encouraging people to switch modes when there's availability on the transit network, as well as there's parallel arterial opportunities at several areas along the highway network. And they wanted to take advantage of those opportunities if the diversion would allow overall corridor traffic to reduce, delay to reduce on the overall corridor. And now let's talk about how we're going to do that, or how they are doing that. So this is a visual graphic on how SANDAG, the Integrated Corridor Management System, is managing a decision support system response. So the solution itself is constantly monitoring the traffic conditions, predicting traffic going forward 15 minutes, 30 minutes, and an hour. And then when we do start to see predicted congestion, then we will start to propose a set of mitigation measures. And those mitigation measure consists of, well, do we then use ramp meters to reduce the amount of traffic coming onto the freeway? Do we start diverting traffic onto some parallel arterials using the dynamic message signs on the highway, and then also using the arterial network and increasing the throughput on the arterial network to deal with that traffic that is going to be diverted? And also, or do we actually provide recommendations for transit? Once we propose those mitigation measures, we need to evaluate which set of mitigation responses are the best situation. In other words, gives us the best reduction in overall delay in the corridor. So with that, then we do the analysis of a set of response suites, again, using microsimulation modeling, analyzing those results, coming up with what is the best opportunity and the best set of plans and mitigation measures to reduce overall corridor delay. And then that's the one that the agencies, all in cooperation, would have to implement. So now let's look at how this looks like from an operator's perspective. So this is an operator's view of what's happening on the corridor, as well as the DSS engine proposing 3 different options. Now, so there's right in the middle of your screen, there are essentially on the right-hand side, there's a do nothing case, and there's 3 options. They both consist of an arterial diversion around the incident location. Okay, one is a short diversion, then there's a little bit longer arterial diversion, and then it looks like a combination of 2 diversions around the incident situation. So what we're doing here is we're actually showing them at the top of each of those, there's actually a reading. Plan A set of mitigation measures, which includes an arterial diversion, looks like on a single arterial, gives us an overall improvement in delay of 3.47 in terms of a delay reduction, percentage-wise, that is. And that's not just on the arterial and the network and the freeway, that's on the overall network in that area. Okay, the overall corridor network, which includes all the arterials. Plan B gives us a 5.23% overall reduction, and Plan C gives us a 6.6%. So Plan C will be the selected option. Now, the way these plans are implemented is they're implemented, can be implemented semi-automatically by an operator, or if the agencies all agree, they can turn it to an automatic mode where after a delay time period, it would automatically be implemented. Now, this program has been ongoing for several years now. The system was deployed about 8 years ago now, and the agencies have been working together to fine tune it and over time. And they meet regularly, analyze the performance results, and refeed that back into the solution. With that, I just wanted to sort of summarize by, we have a number of iNET clients around the US and in our neighbors to the north, Canada. And these are leveraging our iNET solution to improve traffic conditions on their transportation networks. With that, Samir.
Great, that was amazing, Richard. Thank you for that briefing. You know, I'll tell you, when I look at the examples you shared with Dubuque and SANDAG, you know, what really pops out for me around how you're leveraging AI in those examples and with iNET is the use of a micro simulation, right? Prediction, right? To predict congestion, you know, 30 minutes out, you know, an hour out, and then be able to assess the efficacy, right, of multiple traffic relief plans, and have the AI recommend, right, the best plan that should alleviate congestion, right? That capability, I think, is not widely used, right, across state and local DOTs, but certainly I think one of the most unique capabilities that pops up for me and hopefully for others that are on the call. So
it is. It's not widely used, but it's starting to be used in the last several years, and more jurisdictions are building it into their solutions, into their integrated corridor management solutions. We're working on a number of projects for agencies across the U.S. In the Buffalo area, we're working with the NITEC agency on a project there, including this type of technology using microsimulation modeling as well. So there are other agencies that are looking at these types of solutions. And, you know, obviously with our relationship with Microsoft, we're also looking to leverage better AI capabilities to give us better decisions. And maybe there are other solutions available that are able to achieve results using those types of techniques.
Great. Thank you, Richard. I appreciate that briefing. So I'd now like to hand it off back to Guada to talk about the future. So many of you probably read some announcements recently from Microsoft about how we are doubling down on AI with our partnership with OpenAI and a suite of new capabilities leveraging generative AI, right, which is really a subset, right, of AI, and how we can leverage generative AI and GPT 3.5 and future versions of GPT into iNET and other solutions to really take it to the next level. And I'm going to ask Guada to sort of talk about what that might look like, right, for traffic operators within the TMC for DOTs. Guada.
Yes, thanks, Samir. And yes, we in Parsons, we continue investing in innovation. And I think that iterating on advanced capabilities on the cloud and bringing advanced AI generative AI, thinking about how can we bring more of this intelligence to iNET. I described before the different modules. Richard talked about the use of simulations and advanced capabilities to ensure that we can really unlock efficiencies, continue investing in security and upgrading the infrastructure of the society. And for that, we can think on how do we move from simulations to think about having a companion. And we really like this concept of having the copilot of the operator, where basically you can start thinking on how can I adjust the speed variations, considering that I have certain traffic pattern, or if I need to create a plan, it's creating a plan for an event that is happening that can cause congestion around an area. And then starting having that dialogue, that partnership with the intelligence that really help us to understand, is this similar to the previous plan? Do I have to consider another variables, and help to have this, again, companion partnership that helps guide the decision of the operator. And we also, of course, care about the environment. And think about in the scenario of snowplows, where we can provide with the capabilities to make decisions around the right and accurate use of materials, where by using ChatGPT, you can understand exactly what is the amount of material that you need to deploy a certain operation. And then in addition to that, you can really protect ecosystems around, just considering, do I have a river? Is there agriculture activity around this? So I have to basically set down some constraints to the plan that the operator will deploy. And again, going back to this partnership, at the end, is the operator the one that is in control? We want to empower our customers on this. And we believe that with the partnership with Microsoft, betting on responsible AI, safety, trust, we really can make a very, very solid solution together that, again, we can help upgrade this infrastructure for societies across the globe. We are very excited.
That's super exciting, Guada. I mean, the very idea of having a AI co-pilot seamlessly integrated into an ATMS system, supporting the traffic operator, being able to enable the traffic operator to leverage natural language prompts, right, to gain information in real time to support, traffic management, traffic relief response. Is just mind-blowing.
Being able to leverage just real-time information, where in this business and in this industry, it's important to have the speed to make the decisions and the right decisions. And I think that if we can empower the operators and the users to really come with all those perspectives and variables, I think this can be really, really impactful. And again, going back to our mission, right? We want to protect and connect communities. The more information that we can gather around that, the more efficient we can make this. So definitely very promising. And just sharing with you, we are really, really serious about this and making investments. Again, our partnership is definitely a solid step towards that. And we see that in the future, this industry will be really benefit of bringing this innovation.
Absolutely, we're super excited about the partnership as well, and I'm looking forward to the day, right, where we see Copilot, AI Copilot integrated in iNET sometime soon. So with that, we just wanted to end with a link to where, if you're looking for more information around iNET and how it works, there's a web form that's available for you to fill out. Guada or Richard, if you don't mind throwing that in the chat, feel free to populate that. That'll go to the Parsons team, and they can contact you to learn more about the entire suite of intelligent management modules within iNET, or any other questions you may have for Parsons about how they're really leading the way, right, in leveraging AI to transform transportation for DOTs. We've also provided our contact information in this deck, which you'll get a copy for. So if you have any questions you want to ask us directly, feel free to contact us, and we're happy to answer any questions you have. And with that, Deanna, I think we are wrapped on this end.
Thank you, Samir. We would like to go to the Q&A portion of today's webinar. We do have quite a lot of questions. So Samir, do you want to kick things off with this first question that we have? It says that AI can be very different things. I assume pattern matching is supported, but are other more advanced forms of AI, such as neural networks, supported too?
Yes, it is. And I think the example, you heard some examples from Richard around how neural networks are actually being leveraged, right, within the iNET platform. I'd like to ask Richard to maybe expand on how that's actually being leveraged.
Well, specifically with regard to neural networks, we're actually leveraging some neural network libraries in our video analytics module, okay? And as such, that's the one area that at least right now we're leveraging it. That has actually gone quite well. We've actually deployed that at a number of sites, and we're actually looking at leveraging. It was kind of more of our test case, I would just say. And we're kind of looking at leveraging that technology in other modules as well within iNET.
Thank you, Richard. We'll go to the other question. It says, what kind of sensor is iNET compatible with to constantly monitor conditions? Example might be LiDAR, CCTV, connected vehicle data.
I'll just say pretty much everything available on the marketplace. I mean, we started off in the days of loops, okay? So we were collecting data from loop detector technologies. Then we advanced into non-intrusive detectors like using radar detectors. There's about 5 or 6 good radar detector manufacturers available in the US. LiDAR, we've only started seeing the deployment of them fairly recently. But then again, as long as they're committing to using standard protocols for publishing of their information, then we can connect with them as well. Video detection systems. So not only do we have our own video analytics solution, but we integrate with others that have video analytics solutions. A couple of examples are things like CityLog, Fluor. There's a lot of other manufacturers that have video detection systems that we integrate with as well. Connected vehicle data, those are available from a number of third-party probe data suppliers, which we integrate with. So it runs the gamut. And if we actually are working with an agency and they're interested in a different technology, we are able to customize an interface to that technology as well.
And this other question is also for Richard. Someone wants to know, how does iNET's DSS handle response plans for events that are close by each other and that use the same resources? And they're saying that they're not talking about VMS who have a priority of algorithm inside, but for example, traffic signal controller and ramp meters who don't have such internal.
That's actually a really good question, because that's why we, for example, the SANDAG project where we initially developed this technology, we actually don't look at individual events and the mitigation measures for individual events. We look at the entire corridor. And that's where the beauty of this method comes in. I mean, I would just say it's very resource intensive to look at an entire corridor, but it actually works that way. So if we have, say, 2 or 3 incidents within the same corridor, we're running a microsimulation module in the entire corridor with those incidents defined. And as such, it's determining the predicted traffic that'll be the outcomes within, say, 1 hour or half an hour. And then the plans that we come up with using our rules base, all those plans are then analyzed on those incidents that are there. So we're not just looking at single incidents, we're looking at the entire corridor with those incidents on it. Okay, I hope that answers the question.
Thank you, Richard. And another question, someone says, curious how an in-vehicle V2X application can confirm that accident has occurred, or can you elaborate?
A V2X application confirm that an accident has occurred. Not sure what the question implies, but essentially the V2X data that we're actually getting are typically these days coming from third-party V2X or third-party CV suppliers.
Yeah, and Richard, I think where this question is going is around, as we know, there's connected vehicle data from connected vehicles. Some of the telemetry, right, that's being fed includes may imply, right, that that an accident occurred. For example, an airbag was deployed, or there's a harsh brake, or combination of harsh brake and a airbag deployed. And I think the question may be around, picking up those signals, and does Parsons able to take in those signals, evaluate whether that is an accident, and then take action.
Yes. Okay. So that clarifies it. Thank you, Samir. And that's actually what we're actually doing now, because there's not a huge amount of CV information out there directly from CV, connected vehicles. But when that starts to happen, those are the sort of things that we expect to see using the standard protocols that are available to us. Like you said, if there's a hard braking happening with a number of vehicles, not just a single vehicle, but a number of vehicles in the area, well, then more than likely there's a high potential that there's actually an incident in that area, probably just downstream of that hard braking. And that's where we can leverage that sort of information within iNET.
Thank you, Richard. And another question, how is privacy protected with the tracking of vehicles and pedestrians?
Sorry, I didn't think the first part of that question.
Someone wants to know, how is privacy protected with the tracking of vehicles and pedestrians?
Hang on, I think I need to open up the Q&A because your audio is not coming through, Darina.
I could rephrase, Richard. Yeah. So the question was, how is privacy protected with the tracking of vehicles and pedestrians? So when you ingest that data, right? Yeah.
I think this is probably more as it deals with the video analytics module, because that's where we're actually tracking, identifying and tracking objects, and we call them objects. So there's no personally identifiable information on that object. And the data that's collected on that object is really, well, we have an object, it's of this type, either a pedestrian or a vehicle. We try to classify the vehicle, whether it's a motorcycle, a car, a light truck, a heavy duty truck, that sort of thing. But we don't capture any personally identifiable information about that object.
Thank you. Just want to make sure that you can hear me well, and I'll try to get through as much as the questions as we can, because we do have quite a few. Someone else wants to know, do you allow end users, client system admins to configure the business rules for the AI? If so, what commercial product you have integrated with?
Okay, just where it comes to it, yes, we do. We're configuring the AI, for example, the AI inference engines that we're actually using in our traffic signals module for the traffic response control. The AI can be configured. The rules, the thresholds for them can all be configured by the end user if they so wish. I mean, we set them up essentially based on the network, transportation network in the area they're being utilized, but they can be used. In some cases, we've developed it ourselves. We've used a third-party AI library or engine that's integrated into our product. In some cases, we have an agreement with that company, and we don't announce exactly what it is, but we do allow them to configure the rules that actually drive that.
you. And another one, do you care for microsimulation tool you're using? Is there a specific one?
Well, there's ones that we've actually used. For example, in the SANDAG project, we used AIMSUM, and we're also using AIMSUM on the NITEC project in the Greater Buffalo area, in the Niagara Frontier. So that's ones that we've actually leveraged in those two products or projects, and it's what we use. Again, the microsimulation model itself is configured and set up by our partner, AIMSUM in this case, and it's actually leveraged and integrated with our iNET solution to provide essentially a holistic prediction capability and analysis of traffic mitigation measures.
And another question here, are you telling us that when an operator asks a question to the AI, that the Microsoft AI is able to know the agency's standard operating procedures of how to respond?
I think that's kind of a futuristic question because, and what I could see, and maybe it's something that Samir Guada you can address, is using something like ChatGPT. If it has knowledge of the agency's policies, and if it has knowledge of the operational SOPs, okay. I mean, I've used ChatGPT for some things and already just as an ad hoc test, and I've been surprised at the actual results it's giving. I think this is a whole area where it's exciting to find out how these technologies can be used and whether they can be used that way. I think it's a potential. How good it would be, I think the results are yet to be seen. Samir, Guada, do you want to add to that?
Yeah, I can chime in, Richard. I think that's spot on. I mean, this is kind of what Guada was sharing around looking into the future, how Parsons can leverage the OpenAI service we have and leverage the large language model that's already available, plus train it against existing data, right? Within iNET, and then integrate that right into iNET to enable natural language prompts, right? From the traffic operator to engage with and get answers to questions. And that's, again, trained on data, not just of what's available on the internet, but also specifically training the model around data that's housed right and under the hood for iNET. And that's something that we're going to be testing very soon.
Yeah, and you totally mentioned something that is very important, and we show in the example that we presented before is really how do we ensure that we can cross all these feeds of data. We have historical data, we have data of the current operations, and we have data that is being fed from different sources based on other experiences. And considering, again, privacy, security of the data, we can cross them, and then the intelligence will help us answering questions in record time, that you will give the operation this empowerment to make the right decisions. We have to test which are the best scenarios for this, what is the data that is available today. I think we have a question that probably will come later, Diana, that talks about how much can we trust on the answers of these technologies. This is a partnership. Think about this, it's really a co-pilot, it's not a pilot, right? So is how do we start partnering with the intelligence to provide us with the right insights so the operator can start making the decisions. And it's a learning process, and we are going to go through some iterations. Again, the partnership with Microsoft is strategic because of the responsible treatment of AI and these emerging technologies, but it's promising what we can unlock, especially again, in terms of the efficiency that is required for these type of scenarios, and to really help protect the infrastructure and the people.
Thank you, Guada. And sort of following up on the ChatGPT, someone wants to know, how do we ensure ChatGPT and similar predictive language models yield correct insights to to the sometimes jargon-filled, very human world or traffic operations?
Yes, well, and first of all, I think that safety is one of the key priorities for Parsons. Okay, so we continue iterating on that, and our foundation is based on the protection of the communities. So we will ensure that as we deploy these technologies, we
I think we lost Guada. So Samir, I don't know if you want to pick up.
Yeah, I can take that. So,
which are the use cases
oh,
that
there
can
she-
be.
Guada, you there?
Yes.
Great. Okay.
Okay. So iterate in the next basis of what can be real, can be implemented first. This is a roadmap, basically. You start with some scenarios and then we iterate as the intelligence learn more and we trust in the technology maturity. So we want to bring this responsible again. That's why for us, the partnership with Microsoft is a strategic because of the experience working in enterprise and in these scenarios itself. But definitely want to do this responsible and make sure that we deploy these once is ready.
Thank you. We're definitely coming up on time, and I'll try to get through just one or two more of the questions here. And one question is saying, what are the challenges and limitations of implementing AI in the traffic management? How long does it take to train the models? Are these models customized by location and potentially event type? And are they automated pipelines for training modules, and as the automations are manual?
Yes, no, we definitely are setting an infrastructure where we can automatize some of these processes. And yes, there might be configurations that we need to make depending on the scenario. Again, this is a learning process, so we will go through some iterations. Today, as Richard described before, we have using technologies close to AI or on AI that basically will help us with video analytics. We use simulations, so we do have a solid technology foundation. As we iterate on bringing new technologies to it, we will continue enriching that foundation itself. But again, being concrete on the answer, there might be some scenarios where we want to customize to a specific situations, but we will provide the right infrastructure for it.
Thank you, Guada. And thank you so much, Richard and Samir. I do apologize that we didn't get a chance to go through all of the questions, but their contact information, it is listed on the screen. So do not be shy about reaching out directly to them with any additional questions that you have, and they would be more than happy to set up some time and talk more about these questions. I would also like to take this time to mention another upcoming webinar that we will be having, and that is April the 18th. And Carlos will drop in or the link to that webinar that is coming up. And it is, I'll give you the title real quick. It is Digital Transformation Strategy for State DOTs of Tomorrow. And that will be with Virginia Department of Transportation along with Microsoft. So hopefully you all can join us again and we will have a wonderful discussion. Thanks again, and hope to see you next time. Take care.
Thank you.
Thank you all.
Thank you for the opportunity.
Thanks.